Saying? Yes, Priyanka? You were saying something in the chat box? Is your mic not working?
So it is
No,
not.
Priyanka, your mic is off. Turn your mic on. You haven't turned it on. Now try speaking. Say something. I think she's having some connection issue in the mic. Okay, yeah. Try joining again, or try joining from a different ID if you have a. Also, you guys should make sure that you have two IDs. Many times, what happens if one of the ID is not working, thereby you can join from the different ID. Okay, no. So we were doing the chapter physical and please make me co-host. Yeah, hello, please make me co-host. Yes, Abu, you got your Priyanka, you got your mark sheet. Okay, okay. See, actually, I'm not the co-host of the meeting. There, I was making a call. So just give me 1 minute till I made the co-host of the meeting. Yeah, okay. Priyanka, you have got the marks of, you have got your mark sheet of the text exam conducted in your school, you are saying. Okay, okay. Share it with me. Okay, now share to the share to the operation team. They will be sharing it with me. Share to the team. Okay, you got 18 and a half. Okay, out of, very good then. Good. That's a good marks. So we were learning about chemical changes. We learned that a chemical change is always accompanied by either one or all of the following. Heat will be released or heat will be absorbed. Sound will be produced like a firecracker, burning of a firecracker. Color of the substance will be changed. There will be change in the smell of the substance. Gas can be formed in the reaction, right? Now, or the solid you can be solid. Solid residue can be formed. We have several examples of that. We learned about that. We learned about the rusting of iron as well in the previous class. We learned about this one too in the previous class. So we learned about this one in detail, and we learned that too also, that how we can prevent iron from rusting. There are various ways of preventing it. Either you can prevent it by galvanization, basically depositing a layer of zinc on the iron. That is done through electroplating. Or either you can make alloys of iron. Basically, you can make steel that is made up of iron and carbon, or you can make stainless steel that is made up of iron, chromium, and nickel. We learned about those things in the previous class. We learned about chemical changes in everyday life also. So these things we have learned. Today we'd be learning about burning of magnesium ribbon. Then we would be learning about reaction between copper sulfate and iron. Okay, now these things we are going to learn. All these are the examples of chemical reaction. We are going to learn some important chemical reactions like reaction of magnesium with oxygen. What does happens when you burn a magnesium ribbon? Then what would happen if you were to take a rusted iron blade? This is a razor blade. When you dip it into a copper sulfate solution, what will happen? Why does the color change to green? Uh, why does that happen? We would be learning about that in today's class. We have this animation, we have the video also, would be explaining that one too. Then another important chemical reaction is a reaction between vinegar and baking soda. Reaction between vinegar and baking soda, that is also one such example. You'd be learning about that too. Later on, you would be learning about crystallization. We would be this is an important topic. You'd be learning whether it's a physical or a chemical change. We'd be learning that too. So these things we are going to be learning today. Let us begin. Furthermore, if you guys have any other questions, please do let me know. Yes, Abu, you are also required to turn your camera on in the class. Okay. So burning of a magnesium strip. See, here you have taken a strip of a magnesium ribbon. You have taken a magnesium ribbon. You are holding it up with a pair of tongs. And as soon as you bring it close to a burning candle or a burner, this is called as a Bunsen burner. That is a Bunsen burner, and this is the type of burner that is available in the laboratory. This is in the Bunsen laboratory. But this is a uh, Bunsen burner. Getting it now? So what basically happens? You are burning it over this candle flame, and it will start to burn with a dazzling flame. Upon burning, it gives uh, a dazzling flame is observed when it is burned. So thereby, in this, basically what is happening? This magnesium is reacting with the air, with the oxygen present in the air. The reaction is as follows: magnesium reacting with oxygen thereby leads to formation of magnesium oxide that is white in color. And here you have placed a china dish. So this debris that you are seeing that is falling over here, that is basically magnesium oxide, which is a white powder. So here you took a small piece of magnesium strip or ribbon. Upon bringing, also many times you'd be required to rub it using a sandpaper. You'd be required to rub the tip of the magnesium ribbon using a sandpaper, because what happens, the magnesium would slowly, sometimes it would react with the oxygen in the air on its own without even being heated. So you have to remove the layer of magnesium oxide before burning it. Let me repeat what I say, that what happens, sometimes magnesium reacts with air, and a layer of magnesium oxide and a layer of magnesium oxide deposits over it. Magnesium oxide deposits over it. Hence, we need to scrub it. Hence, it is scrubbed using a sandpaper. Using a sandpaper. Is that clear? This a question like this is usually asked in the exam. Why do we need to um, scrub the tip of the magnesium ribbon using a sandpaper? Because it can slowly react with the air and can lead to formation of magnesium oxide. That is the reason. Is that clear to so far? Clear to both of you? Hope it is clear. Abu, is it clear? Both of you, turn your cameras on. Please do respond in the class. If you'd be guys, if you guys will stay silent, then how will I know whether you have understood it or not? Well, at least you should turn your camera on in the class and your mic. See, studying should always be a two-way interaction. If the teacher would be speaking and you would stay silent, then how are we going to have a interactive class? If Priyanka, try saying something. Is your mic still not working?
Sir, I was putting my device on charge.
Okay. No issue then.
Sir, I will on it after some time.
Okay, no worries. So that is the thing why this is the reason why it has to be stripped. Okay, Priyanka, it's still not working. Okay. Anyways, so that is the reason. Now, in the form of an equation, you can write it like this: magnesium magnesium reacting with oxygen gives you magnesium oxide like this. Color of magnesium oxide is white. Now, there's an interesting thing about this that um, this magnesium oxide now this is basic in nature. This is a metallic oxide. This magnesium oxide, this is going to be basic in nature. But how do we prove that it is basic? We learned previously of the chapter acid and bases. Hmm? Didn't we learn this thing in that chapter? A metal would be reacting with oxygen to form a basic oxide. If not, just know this concept that this magnesium oxide is going to be basic in nature. How are you going to prove that it is basic substance? So you will gather this mixture, gather this powder, take this white powder and add some water to it. Okay, now and mix it properly, stir it properly. So thereby you have a aqueous solution. Aqueous refers to water. So any solution in which water is present, that is called as aqueous. Aqueous. So you have an aqueous solution of magnesium oxide. So it can be written in the form of an equation like this: magnesium oxide reacts with water to give magnesium hydroxide. So here a chemical reaction is again taking place. In the first case, we saw this chemical reaction where a new product magnesium oxide was being formed. It is completely different from magnesium and oxygen now. A new product was formed. It's a chemical and irreversible reaction. Then again for the second time, while testing for the nature of magnesium oxide, whether it is basic or not, you would be mixing water to it. In the process of doing so, also you observe that a new product, magnesium hydroxide, is formed, MgOH whole 2. Getting it, guys? MgO plus H2, that is magnesium hydroxide. So magnesium hydroxide is another new substance formed by mixing magnesium oxide with water. So isn't that the second example of chemical reaction we are having right here? Right, guys? Now, we were learning about that we have one more aim from this reaction. We want to know the property of magnesium oxide also. So what you are going to do now, you'd be having a beaker. In this you have the solution of magnesium oxide and water, that is MgOH whole 2. That is the chemical formula. The name is magnesium hydroxide. And to test whether it is basic or whether it is acidic, you guys tell me, what should I be doing? Whether I should be putting a red litmus or blue litmus? You guys are going to tell this. I won't be telling this. We have learned this previously. Recall the concepts, then answer this.
Red.
You'd be taking a red litmus paper right now. So you dip a red litmus paper into it. Then what is going to happen? The color will change to the color of the litmus paper will obviously change to what? Blue color, no? And we know that basis turns red litmus paper to blue. We have learned previously that basis turns red litmus paper into blue color. So thereby that is the test for this substance, that this is a basic substance. This is a magnesium oxide is basic. This is also basic, and its solution obviously is also going to be basic. So we can conclude one thing over here, that MgO or magnesium hydroxide is basic. Is that much clear so far to you or not? Yes, Abu, did you understood this?
That is clear. I understood.
You understood it? Okay, Priyanka, what about you? We can also answer in the chat box. So that was one such example of a very good. So far, let us summarize what are the is important chemical reactions we have discussed. Although you get to see lots of chemical reaction in your daily life, huh? Like you have respiration, photosynthesis, cooking of food. All those are also these are the chemical changes happening around us. But the important chemical reactions are the rusting of iron first. Then you have second example as you have second example. By the way, these are also the general examples of chemical reactions that we see in everyday life. Cleaning a tile, combustion of fuels, softening of hot water. The special cases is the rusting of iron and this one, burning of this magnesium ribbon. So the evidence that this is a chemical reaction is that because a new substance is produced, it's having a different chemical property than oxygen and magnesium. Like oxygen is a gas, magnesium oxide is a solid substance. It is breathable. You can't breathe this. You use we need oxygen for respiration. Magnesium oxide is a different product having property different from oxygen and from magnesium. So that is the thing about it. Next, we are going to learn about reaction between copper sulfate and iron. First of all, have a look at this video over here. Look at it again. You took some powder of copper sulfate. You put some powder of copper sulfate, added water into it. You have a copper sulfate solution. You are putting it into this test tube. Then now you have put a iron nail into it. Now you tell me this part of the test tube. In this part, the copper sulfate is blue. As you move slowly over here, the color is changing to greenish now. Isn't that, guys? Yes, Abu? That changes to green now. Further, see, it has changed to green, almost green. Right now, and after a long period of time, the color will basically iron will start to wither off. So basically, what is going to happen over here, as you have put an iron object into it right now, so thereby iron will displace the copper from it. This is basically CuSO4 reacting with iron. The symbol of iron is Fe. So thereby this will replace the copper from copper sulfate. Thereby it forms FeSO4. FeSO4 is nothing but this iron sulfate. CuSO4 is basically copper sulfate. Its color is blue. But iron being a more reactive metal than copper, it displaces copper from the compound copper sulfate. It will displace it. Simply, it will kick out the copper from here and now forms a new substance called as iron sulfate. And look at the color, it is now green. Getting it? Is that clear so far to everyone? Yes? Abu, have you understood this? And Priyanka, you guys understood this now?
Yes, sir.
So that is the reaction between copper sulfate and iron. And this the changes that you observed here, it is due to a reaction taking place between copper sulfate and iron. The color of the solution from blue to green is because of the formation of iron sulfate, a new substance. Right now. Furthermore, if you were to look at this animation over here, you would have observed that the there's a deposition on the iron nail too. This brown deposition. So what is that brown deposition? That brown deposition so that brown deposition is basically copper. Copper has deposited over it. Copper has deposited over it. So you can observe this one too. Tell me, can't you observe the difference in the color of this iron this razor, this iron blade and this iron blade? Don't they look different? Miss Abu, Priyanka? So they do look different because there's deposition of copper above it. So that is the reaction. Two things you are observing. You have observed a new product, iron sulfate is formed. Then you observe that the color of copper sulfate changed to greenish because of iron sulfate. Also, where will the copper go? So copper will simply deposit over the iron. So hope you have understood this. If there's any doubt in it, please do let me know. In the form of a reaction, you can write it in this manner. Copper sulfate solution that is blue in color reacts with iron to form iron sulfate solution, and copper would be depositing over that iron object. So that is another example of a chemical reaction. Hope that is clear. Is it clear or not? You guys are not replying. You guys have stopped replying. Why is it so? Yes, Abu? Are you guys not understanding the concepts? Is that the reason?
No, sir.
Then you have to try to not just agree to if you understood the concept, then just agree. Only then I will be proceeding further to the next topic. Okay, now? Because if I want, I can just finish the whole chapter in just one class. But it is important that you understand the concept now. Getting it now? Okay. So further, we are going to talk about reaction between vinegar and baking soda. Okay, now? So these are the compounds you are so far familiar of. So let us understand about reaction between vinegar and baking soda. Where do we use vinegar and what acid is found in vinegar?
Acetic acid.
Which acid? No, that is not citric. Did you say it's citric acid? Priyanka, answer in the chat box what acid is found in it. You have answered it. Acetic acetic
Sir,
acid.
I said acetic acid, not citric acid.
Oh, sorry. Then. That is acetic acid is found in it. Very good. And baking soda is basically a base. Vinegar is an acid. Baking soda is basically sodium bicarbonate now. That is sodium bicarbonate. That is what baking soda is. So what would happen if you were to, even if we can perform this at our home also, what we can do, we would be taking some vinegar in a test tube like this. Take some vinegar and add some baking soda. This whitish patch, white thing that you see in this, let me zoom it out. That is baking soda, because baking soda is white in color. So we have added baking soda and vinegar together. Now close the mouth of the test tube using a cork. Using a cork, you know what a cork is. It is used to used to close bottles. Particularly, it is there in the alcohol drinks. It is alcohol drinks are closed using this cork. It's basically a wood. It's basically a wood, and you would make a hole into it, and you have put a bent pipe into this. Right now, so you have put a bent pipe into this. So what would happen? The vinegar and baking soda would, first of all, they would be reacting. You'd observe that the bubbles, gas bubbles will start to come out of the mixture. After a few minutes, vinegar and baking soda, upon reacting, it will start to release some bubbles. So those bubbles are basically carbon dioxide gas. So in this test tube, CO2, that is carbon dioxide gas, will be formed due to reaction of vinegar and baking soda. But then someone asks you, how will you test that this gas that is produced in the reaction is actually carbon dioxide? It's not a nitrogen dioxide, sulfur dioxide, or a different gas. How are you going to prove that? You can simply do it by putting this tube into another test tube in which you have taken lime water. You know what is lime? That is calcium oxide. But what is lime water? So lime water is calcium hydroxide. That is simply calcium hydroxide. So you have taken lime water. Basically, you can take some lime. It is the same lime that is used to paint house. Even in villages or earlier, like earlier, you hadn't so many companies of paints. No? Nowadays, you have so many different companies of paints. So earlier, how people used to paint their homes, they would be using this lime. They would be mixing lime in water, and then lime water is ready. So you have taken it into another test tube. Now the gas tube, from this test tube, this carbon dioxide gas will go into this calcium hydroxide solution. So what happens? Also, you can keep this in mind that this tube is dipped inside this. It is not above the solution. It is dipped into the lime water. So thereby you will slowly observe after a few minutes the color of this calcium hydroxide, that is lime water, will start to turn milky. It turns milky because carbon dioxide gas will be react with it. So if the color of lime water changes to milky just like how milk looks like, white in color. So the color of this lime water will turn milky, and this is the standard test that upon reaction of vinegar and baking soda, carbon dioxide gas is released. Do tell me, have you guys understood this or not?
Yes,
Yes,
sir.
Okay. Priyanka, what about you? You can answer in the chat box whether you understood this or not. So here basically a chemical reaction has taken place now. And in this basically carbon dioxide gas is released. So how do we prove this? We prove this in the following manner as we discussed. Okay now. Or in the form of an equation, if you want, I can also represent in the form of an equation, like what is happening in this test tube. Like in this test tube, what basically happens now? You have um, lime water and you have the baking soda. Vinegar and baking soda. Vinegar basically contains acetic acid, that is CH3COOH. That is a formula of acetic acid. This would be reacting with the baking soda, that is NaHCO3, sodium bicarbonate. and that will lead to formation of following things. Carbon dioxide gas will be formed, water will be formed in it, and this one more component, that is a salt, will be formed in it, NaCH3COO. NaHCH3COO. So thereby this is the reaction that is happening. By the way, this salt, that is sodium acetate. Although this is not much important, so just I'm telling you that is sodium acetate is formed. But the main thing that you need to keep in mind that carbon dioxide gas is reacting. Sorry, I mean to say that uh, vinegar would be reacting with baking soda to release carbon dioxide gas. This will go into another test tube where it will be reacting with the lime water, and it will turn it into milky. If some you had a question in your mind like what would be left into this, so this sodium acetate will be left along with the water into the test tube, first test tube. Okay, now. So hope you guys have understood this. Is that clear to both of you now? Furthermore, we're going to learn about crystallization. Okay. So talking about crystallization, it is a process of obtaining crystals of a pure substance from its solution. It's a process of obtaining crystals of a pure substance from its solution, basically. In this chapter, we would be learning about how we would be able to obtain crystals of copper sulfate by boiling copper sulfate solution. Okay, now. So what you're going to simply do, how you're going to carry out? First of all, see over here. In the following image, what you have taken a cup full of water. A cup full of water will be taken in a beaker. In this beaker over here, you have taken this beaker in which you have taken water, and you are heating it. So the water, it will be heated, and when it starts to boil, so thereby just above it, put a copper sulfate solution in a china dish. Understood the first setup now? You are not directly heating the copper sulfate solution, you have placed it above a boiling water. Getting it? And you will this copper sulfate solution is very concentrated. Let me take a different setup. See what you have simply done. You'd be taking a cup full of copper sulfate. You'd be taking a beaker full of water. You will be heating it. So it will start to boil. So it will start to boil, and then you will be taking another cup. This is called basically a china dish. You take a china dish and you would put some copper sulfate, powders of copper sulfate into it. Remember the blue color copper sulfate powder? Moments ago we learned about that reaction of copper sulfate solution with iron. Same thing we are doing over here. So you would put some copper sulfate powder into
Sir, I
it.
cannot hear your voice.
Hello, am I audible now?
Yes, sir, now you're audible.
Okay. So what we are doing over here, you have taken a china dish and you're putting it above this boiling water, and you will keep, also you would be adding some water into it also, because you have to take a solution, and you will keep on adding more amount of copper sulfate into it. Copper sulfate powder, and you will keep on adding copper sulfate powder into it until no more powder can be dissolved into it, until no more copper powder can be dissolved in it. Basically, you are making a concentrated solution of copper sulfate. You have seen like how the sweet maker would be preparing sweets. He would be adding lots of sugar into the water and boil it. You have heard of this dish? I mean to say this thing, jalebi. Ever eaten this? Yeah.
No, sir.
So no, if you come back to India, then eat this. Okay, no, it's a sweet. So basically, what happens after it is cooked, it is dipped into a very thick liquid. That liquid is basically made up of water and sugar. And while that liquid is prepared, lots of sugar is added into it, and they keep on adding sugar into it until no more sugar can be dissolved into it. So it's a very concentrated solution. Same kind of similar thing you would be doing here. You'd be adding lots of copper sulfate powder into it until no more copper sulfate powder can be dissolved into it. And you will keep on stirring it, keep on mixing it. Okay, now? Then furthermore, what you're going to do, hmm, furthermore, what you are going to do now, you will allow it to cool. Then later on, you will remove the source of heat. As you can see in the second image over here, the second image, you have removed it. You have removed the source of heat and you will allow it to cool. So solution should be left undisturbed. It should not be left, it should be left undisturbed. Also, you can see the water is no longer boiling in this. It's not a boiling water once it cools down. So after some time, you'd observe crystals of copper sulfate in it. You have a crystal of copper sulfate. So let me quickly summarize what we basically learned in this. He basically took a solution of copper sulfate, and then from basically you took some copper powder and added water to it. You had a copper sulfate solution and you placed it above the boiling water. Then later on you will remove the heat and you will allow it to cool. After some time you will observe that crystals will be obtained here. Crystals will be obtained here. So hope you guys are understanding this. Okay, no? So hope you have got this. So you have basically, let me repeat, you basically took um you have basically taken water and copper sulfate powder, you added, you will be keep making a very concentrated solution of it, then place it above this boiling water, and then later on remove the heat. After some time you'd be able to obtain crystals of copper sulfate. So hope that is clear. Is it, Abu and Priyanka? Furthermore, you have some other examples of crystallization also. Like we know seawater is salty, it is saline due to excessive dissolved salts in it. Usually people would be obtaining salts from the seawater via basically via evaporation, but that does not releases the impurity from it now. So salt obtained from the seawater via evaporation is impure and has smaller crystals. So it makes it difficult to see their shape. Their shapes are not regular, it is irregular right now. So we can actually obtain large pure crystals through the process of crystallization. And you guys tell me, like in the previous example of this copper sulfate solution, is there a new product formed in this reaction? Nothing new is formed. You're getting back the same product. Initially, you mixed copper and water. huh? Later on, you after just by removing the this heat, you got back copper sulfate. huh? It's just the state has changed. Crystals are in solid state now. Powder was also actually solid. Then you mixed it, then it become a liquid, and then you're again getting back it into the solid state. Okay, now. So obtaining salt via the process of crystallization is also a physical change. So crystallization involves cooling a hot concentrated solution to create crystals. So same thing you can do. Say that you have a sample of water which contains lots of salt in it. So you want to obtain salt from it. So first of all, you would be heating it. You would be heating this. It's a concentrated solution. You will heat it, and then you will allow it to cool down very slowly. So that is how crystallization is done. So hope you guys have understood that how crystallization is done for salts. Is that clear? The production of the salt and some other crystalline objects happens due to the crystallization process, whereby basically you would be first of all heating the concentrated solution, and then you will allow it to cool. So two things involves heating it and then cooling it. Can you guys think of some other examples apart from these copper sulfate and salt? What objects are obtained via crystallization process? Think of it. You can obtain crystal of almost so many substances. You can obtain pure crystals of a substance from an impure mixture as well. Also, if you have an impure mixture, and you want to take pure substance out of that impure mixture, there also crystallization can be done. Hope you guys have understood this. So crystallization of water. Also, you have this common example, crystallization of water to form ice cubes and snow. That is also one such example of crystallization. Ice crystals, what are they? Basically, they also undergo crystallization. Yeah. Also, have you observed that honey also goes under crystallization? Like in the winters, you'd observe that when it is honey is placed in the jar, no, thereby you'd observe that it will start to solidify. At the bottom, you'd be having solid crystals of honey. Ever observe that, Abu and Priyanka? So you have crystallization of honey, we have crystallization of salts, uh, we have crystallization of copper sulfate, you have crystallization of ice. uh, so hope you guys have understood this, or you can have some other examples now. You guys tell me, what are those gemstone crystals? What are diamond, ruby, emerald? What are those? Aren't they also crystals? Yeah, but that is occurring through a very slow process of that is a very slow crystallization process, the formation of various gemstones. That is also one such example. Or have a look at this image, that would give you a better clarity. See, in the caves now there's a structure like this that you can observe in the caves called as stalagmites. See, this is what I'm talking about. Have you guys ever seen pictures of this thing? What are they? They are also formed through the process of crystallization. Okay, now Abu and Priyanka. They are also formed through the process of crystallization. They are found particularly in the caves, and they are called as stalagmites. Stalagmites. They are stalagmites. So is that clear to everyone now? Then why, how is crystallization advantageous? Meaning that, say, if you want to obtain a highly pure substance from an impure mixture of it, so thereby you can obtain it by crystallization. uh, Furthermore, see, for example, now, like salt, the seawater salt is impure, and it is in the liquid state, so it can't be packaged, and it can't be packed and stored and transported like seawater, saline water. So thereby, will you be able to store it in a convenient manner? Huh? Will you be able to store it in a convenient manner? Will you be able to transport it? So storing of salt water, storing of saline water is difficult. So thereby you would be once you have done crystallization, once you obtain crystals of salt. So thereby it becomes easy to pack it and store it and transport it. So you obtain a dry product from the crystallization process. You obtain a pure product from crystallization. Okay, no. Also, the energy or the amount of work done in order to obtain a crystallized product is very low. You have to simply heat it and then cool it. So what are the advantages of crystallization process? First thing is that we obtain pure substances from it. Second advantage is that we get dry products that can be stored, packed, and transported. Another thing is that the process in itself, it's a very simple process. The energy required to carry out this process is very low. Here, basically, you have to change the temperature. You have to heat it at high temperature, then cool it down slowly. Right now, so energy requirement are low to carry out this process. So hope you guys have understood these things. You would be having so many examples. We learned about example of honey. We learned about formation of ice cubes and snow. We learned about how a honey crystallizes in a jar. Huh? We learned about stalagmites, this interesting feature found in the caves. You would get to observe this in the caves. Hmm. We learned about copper sulfate and about salt. Crystallization, keep that thing in mind. It involves two steps. One is heating, another one is cooling. So also one extra thing, one important thing about this is that it's basically used for it's a kind of separation technique now. You have separation techniques like you have sedimentation, filtration, all that are separation technique now. Yeah, Prinka, you guys would be writing it. Just 1 minute. Let me just complete this. So crystallization is used for separation process now. It is used to separate two products, separate two things. So it's a separation technique in order to obtain pure crystals of a substance from an impure mixture to separate two products. Or to basically, I would say that to separate pure crystals from an impure mixture. So that is the thing about it. Like seawater. Seawater is impure, uh, but after crystallization, you'd be able to obtain pure salts from it, pure crystals of salt from it. Getting it? Okay, so write what I'm highlighting. Okay, write down. I'm dictating and write down. Okay, no? I will be dictating, you guys write it down. Okay. So I'm saying that crystallization is a separation technique. Crystallization is a separation technique crystallization is a separation technique used to crystallization is a separation technique used to obtain pure crystals. Crystallization is a separation technique used to obtain pure crystals of a substance from an impure mixture. I repeat, crystallization is a separation technique used to obtain pure crystals of a substance from an impure mixture. Did you guys wrote it down? I repeat, shall I repeat this again? See, crystallization is a separation technique used to obtain pure crystals of a substance from an impure mixture. If done, then write this examples. No, further one more thing, you need to write down that it is a physical change. Crystallization is a physical change. Crystallization is a physical change. Crystallization is a physical change. After having it written it down, then you would be writing the examples of crystallization. Crystallization of honey, salts, copper sulfate, ice, gemstones, and stalagmites. So that's what crystallization is. It's a process we learn that is we use to obtain. It's a separation technique that we use to obtain pure crystals of a substance from a impure mixture. Basically, here we were basically um, cooling down a very hot and concentrated solution to obtain crystals. Done, very good. Okay, now there are some questions. Abu, are you also done writing it?
Yes, sir.
Very good. See, I'm asking to ask some questions from you guys. These are the questions I believe you guys can already answer. Like freezing of water is a reversible change, while burning of a candle an irreversible change. Huh? Meaning that freezing of water, you can get back the water in the liquid state. While burning of a candle, it's an irreversible change in the following manner that the wax that converts into wax vapor that you can't obtain back. Wick of the wax that burns that you can't obtain back. A special thing about the burning of the candle is that it involves both physical and chemical change. When this paraffin wax, when the wax of the candle melts, you can use it again to make a new candle. You can just melt it into the shape of a candle, solidify into the shape of a candle, and you can make a new candle. But some of the wax is burnt also now. Wax is burning also, and it is lost. So thereby, it's a chemical change. Also, the new products are obtained here. The wax turned into the wax vapor. It turned into unburnt carbon particles. So that is a chemical change where the wax is burning to produce new substance. Right now, to basically get converted into a flame. This flame basically will consist of unburned carbon particles. Furthermore, we can conclude that a candle involves both physical and chemical change. Also, here we can more specifically say that the burning of wax is a irreversible change, while melting of the wax is a reversible change. That thing also has to be considered over here. It's a combination of physical and chemical change both. Burning of candle, that is going to be A chemical change, while melting, that is a physical change. Okay, I had one question for you guys. Do tell me, if I were to drop a piece of sodium into water, will that be a physical change or will that be a chemical change? I were to drop a piece of sodium metal. You know, sodium metal is very explosive, highly explosive metal. Although also it is the softest metal you have, not the softest, but a very soft metal. You can cut it using a knife. So dropping sodium into water, what happens? It interacts with the water and it reacts with the water. No, like you have sodium, that is Na, that reacts with water to form sodium hydroxide and form hydrogen gas. And so much amount of heat is generated when you drop a piece of sodium into water. Now, so much amount of heat is generated that this hydrogen gas burns. This burns with a pop sound. So do one thing.